Alright, these are our notes for section 7.5 on trig applications, and what we're going to do today is extend what we did last class. The only thing different is that we will have word problems and you're going to have to draw your own picture instead of me giving the picture to you, but you will still come up with the trig equation and you will solve the trig equation. So the first thing we're going to do is we're going to do two review problems just to get our mind back thinking of what we've done last class. The first example here, we've got a right triangle. One side is 7, the other side is x. Notice that both of those are the legs of the triangle. It does not give us the hypotenuse, and it gives us one angle, and it says that angle is 30 degrees. So what we need to do is we need to figure out the trig function that we're going to use for this problem. So we're going to go off the angle here. We always go off the angle that they give us, never the right angle, always the angle that they give us. And if we're going off that angle, we want to look at the sides they give us. Well, they give us the side across from the 30 degrees, which is the x, and they give us the one next to it, which is the 7. If we have across, which it would be opposite, and if we have adjacent, if we look back at our trig functions, we've got sine, cosine, and tangent. And remember, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. If we look back at those, the only one that has both opposite and adjacent is tangent, so it's going to tell us that we're using the tangent of, and then comes our angle, 30 equals, and we have to set up our fraction, set up our ratio. And again, for tangent, it is opposite over adjacent. The side opposite 30 is the x, and then the 7 is the one adjacent to it. So there's our trig function. Now we need to solve that. We've got to get x on one side by itself, so we're going to multiply both sides by 7, the denominator, in order to get rid of the fraction, so that the 7's cancel, and we have 7 tangent 30 equals x. Now, since x is on one side by itself, we can go ahead and put that in our calculator. You are going to need your calculator for your notes today and for class next time. Okay, so I'm going to put a star up here. Bring your calculator again that has the 3 buttons, okay, with sine, cosine, and tangent. You have to have those 3 in order to solve this. We're going to put this in our calculator. 7 times the tangent of 30. And when we do that, we're going to go ahead and round to the tens place. If we're finding the side length, round to the tens place, we get x equals 4.0. And there's our answer. We found the answer to the problem. So that other side is 4. Let's look at the next problem here. We've got another right triangle, example 2. This time our angle is an x. Our angle is the variable. That means we're probably going to have to use the inverse in order to find the angle, and we talked about that last time. Okay, but we're going to use the inverse. We'll get to that part in a minute. Let's figure out which trig function we're going to use. If we're basing it off the x here, they give us the opposite side, which is the 4, and then the hypotenuse, which is 15. Opposite and hypotenuse would be sine. So we have sine of our angle, which is x, equals, the opposite side is 4, hypotenuse is 15. There's our trig equation. Now again, since we have a variable in the angle place, we're going to use the inverse. And remember, the inverse, for our inverses, we make it sine to the -1, and then these two switch places. 4 over 15 equals x. And we put this in our calculator, the inverse sine of 4/15. And when we do that, for angles, remember we round to the nearest whole number, we get 15 degrees. Okay, I'm going to make a note of that. Sides round to tenths. Angles round to whole number. Okay, that will continue today. We did that on our homework last time. That's going to continue today as we go through these. Alright, but those are our 2 review examples. We're going to be doing that same stuff today. The only difference is we're going to have word problems. And that's where we get started here with this new idea. We're going to have word problems to deal with today. Before we get to those word problems, we got 2 vocabulary words. The first one is an angle of depression, and the second one is an angle of elevation. Now, they're pretty easy to remember. Depression, like if you're depressed, you're down, you're in a bad mood. So easy way to remember that is that it is down from a line. Okay? Which means if we have a straight line, that is going to go under the line. The angle will be underneath. In our picture over here, this is an angle of depression, and I'm abbreviating it AOD. Because it's going down, it's below that dashed line there. An angle of elevation is the opposite. It is up from a line. Okay? So this here would be our angle of elevation. Now, what's nice about these two in any problem, it doesn't matter whether they give you an angle of elevation or an angle of depression, it's because they are congruent. They are always congruent. Okay? And since they're congruent, we can always just put it down here. Okay? Angle always goes here. It does not matter if it says it's an angle of depression or an angle of elevation. It will always go down there where the AOE is on this picture, where the angle of elevation is. We can treat it as the same thing. So it always goes in that spot. Always works. Remember that, because that is a common mistake on this section of homework, is where the angle will go. It always goes down there at the bottom, regardless of whether it's an angle of depression or an angle of elevation, because they are congruent. Okay? We're going to go ahead and jump into our examples. Now, when we're doing these examples, it's important that you draw a picture. Okay, you have to do that for these. So make sure that you do. You are getting graded on drawing the picture. Some of them will have pictures for you. These three examples do not, so you're going to have to draw your own, which is really easy because all it is a right triangle, so don't overthink it. Let's look at the first example here. It says an airplane pilot flies over a tree and the pilot looks down at it at an angle of depression of 30 degrees. If the plane is 1,500 feet above the ground, how far away is the plane from the tree? So we're going to start with a right triangle. And if you want to make it more elaborate, you can. You can put a plane up here. Okay, there's our plane. You could put a tree down here if you wanted. All right, you don't have to though. Okay, all you really need is a right triangle, and that's all we'll be checking for. Now it says that there is an angle of depression, which is really right here, and it's not 40, it is 30 degrees. But I told you that that angle can always go here, so that's where we're going to write it. The 30 degrees goes down here by the tree. Now it says the plane is 1,500 feet over the ground. Okay, so the distance from the plane straight down to the ground needs to be 1,500, and we are looking for how far away the plane is from the tree, which would be this distance here, from the plane down to the tree. Okay, the direct line from the plane to the tree. And now we have our picture. I'm going to redraw it real quick, just to help us see it, because we've got some extra stuff there. 1,500 here, x here, that's what we're solving for, and then 30. And our angle. Make sure it's a right triangle. Alright, so we need to look at our trig functions. Which one of those goes with this picture? We always go off the angle that they give us, so the 30 here. Well, they give us the opposite, which would be the 1,500, and then the hypotenuse. So that tells us it's going to be sine. Sine of our angle, which is 30, equals opposite over hypotenuse. Now we need to solve this. Now, in order to solve this one, we're going to make this a fraction over 1, and we're just going to cross multiply. So we have x times sine 30, that gives us x sine 30 equals 1,500 times 1, 1,500. That's one way to do it. You could just multiply both sides by the denominator. That does the same thing, whichever way works for you. And we'll do that on a different example, but I wanted to show you this here, that does work. The x still is not by itself, so we're going to go ahead and we're going to divide by sine of 30. And what that does is it cancels these so that the x is by itself, and we get x equals 1,500 over the sine of 30. And we're going to put that in our calculator. Okay, this is why you need a calculator for your notes today, so you can put the trig function in there. And since it's the side, since it's a length of the triangle, we're going to go ahead and round it to the tenths place. So when we put in our calculator 1,500 divided by sine of 30, we get 3,000. And we need to put a label on it, 3,000 feet. And there's the answer to our problem. It is nothing different than what we've done before, what we did in our 2 review problems, except that we have to draw a picture to go with the problem. That's the only difference. Okay, so let's look at example 2. Example 2 says, Joe is looking at a bird in a tree. If Joe is 40 feet from the base of the tree and looks up at the bird at an angle of 42 degrees, how high up in the tree is the bird? So we need to start with a right triangle. And again, you could make this more elaborate if you want. You could draw a tree with a bird and someone looking. But all you really need is a right triangle. And it says that Joe would be over here, is 40 feet from the base of the tree. And he's looking up at it, at the bird up there at 42 degrees. And we want to know how high up in the tree the bird is. We have 2 blanks left. We have this blank over here and this blank over here. This blank would be how far Joe is away from the bird. This blank is how high the bird is off the ground. So this is where we're going to put our variable. That's where we'll put the x. Because we want to know how high up in the tree the bird is. That's what the question asks. So we've got our picture now. And we need to figure out which trig function we're going to use. And remember, we always go off the angle they give us. So we've got 42. We have the side opposite, which would be x. And then we have the adjacent side, which is 40. Okay, so opposite over adjacent, that tells us, if we go back up there and look, that it's going to be tangent. So tangent of our angle is 42 equals opposite is x over 40, which is the adjacent. Now in this case, it's different than the example 1, because we're not going to cross multiply. We could if we wanted. I'm going to just cancel the fraction on this one. So we're going to multiply both sides by 40 to get x by itself. What happens is that those cancel, and we're left with 40 tangent 42 equals x. And that is something we could just put in our calculator. Now we are finding the side again, so we need to make sure we round to the tenths place. And if we put 40 tangent 42 in the calculator, we get 36.016. And we went around to the tenths place. So that just means we are going to get 36.0. And we need to put a label on there. We are talking about feet again. So there's the answer to our problem, 36 feet. Now we have one more example to do. Example 3 says a ladder is leaning against the building for painters to use. If the ladder is 35 feet long and its base is 7 feet from the building, what is the measure of the angle formed by the ladder and the ground? Now for this one, I'm going to draw a picture. I'm just going to draw an elaborate picture just to help you see. Here's my building. Got windows in it and a door. Okay, here's my ladder. And then the ground is down there at the bottom. Now that ladder is 35 feet. And it is 7 feet from the base. The base of the ladder is 7 feet from the building. Now I know this isn't quite drawn to scale. That 7 feet should be a lot smaller. And that is not something I'll be checking on, whether it's drawn to scale or not. I'm checking to see if you've got everything in the same place labeled correctly. And we are looking for the angle formed by the ground and the ladder. So there's where our angle is. This time we're looking for an angle, so we're going to solve it a little differently. We still need to set up a trig equation. However, we need to find the angle this time, which is a little different. We did one in the review problems at the beginning, so if you have questions, look back at those. Alright, we got to figure out which trig function we're going to use first, whether it's going to be sine, cosine, or tangent. Well, according to the angle x that they give us the adjacent, which is 7, the one next to it, and the 35, which is the hypotenuse. We have adjacent and hypotenuse. That would be cosine. So the cosine of x, which is our angle this time, that's what we're looking for, equals 7 over 35. Now, if we're looking for the angle, those two are going to switch places, and we're going to make it cosine to the negative 1. 7 over 35 equals x. And then we can put this part in our calculator. Cosine of the negative 1 of 7/35 equals x. Put cosine negative 1, inverse cosine of 7/35 on our, that's an angle. We round to the nearest whole number. And when we put that in our calculator, we get x to be 78 degrees. And then there's the answer to our problem. Okay? Now, don't get upset if you're still a little lost. Bring your questions to class because I understand this is a hard topic. Trig is something that just takes some practice because you really have to understand how to identify whether it's sine, cosine, or tangent. Okay? So if you're having trouble, I want you to go back and review sine, cosine, and tangent, and then the equation part of it from last class, and look that stuff over. Bring any questions that you have to class, and make sure that you bring a calculator. If other than that, we are all good with our notes. That's the end of our notes for section 7.5 on trig applications using these problems in real life. Just again, make sure you bring any questions and a calculator to class next time. And then that's our notes on section 7.5.